Hello, welcome back to Cracking the Cryptic, and so much stuff about to go on. In a couple of days' time, on the 31st at 10 p.m. our time, Simon's going back into Witness World, and he's going to attempt to keep playing The Witness, and I am going to attempt with a couple of hench buddies to keep the chat stream clean of spoilers. Please don't send them. They're not necessary. He gets through it in the end, and that's fun to watch. So that's going to happen in a couple of days. The very next day will be the 1st of September, and probably around 4 p.m. our time, we will be releasing the new Patreon content for September, which is some puzzles themed on Looney Tunes, some cartoon characters involved and appearing, and a big sandwich contest at the end of that one. So that's coming up. Also coming up, actually, we're getting closer to 400,000 subscribers. We seem to be going up about 1,000 every couple of days, which is fantastic. And I mean, that number's mad, but thank you so much if you have subscribed. Please subscribe if you haven't. When we get to 400,000, we are going to record a video of questions and answers, and we've been having some very interesting questions coming in. We are looking forward to doing that if we get there. Now, of course, there's all our regular stuff. Do get the Sudoku pad if you haven't already. Hundreds of people have, and thank you to those. As well as, I'm going to say thousands of people have bought apps. It might be the same 1,000, but I mean, thank you so much if you've bought our apps. They're available on the links in the description field, and we know there's a lot of stuff to spend your dollars on these days, and we are very grateful if you spend a few on our stuff. It helps us produce more content, and people do seem to like it, so thank you. Right, enough backstory. Now, about, I'm not sure how long, maybe a month ago, Niverio sent in a puzzle that suggested that primes were too cool, and I really enjoyed that one. So I'm looking forward to a very different style of puzzle today called Between the Head and the Tip by them, and I don't know anything about it. I've read the rule set. It's a little surprising, frankly. So between lines rules apply, which mean that the numbers on a line must be between the two numbers on the circles attached. So if you had 1 and 9 in these circles, you could have any other numbers on the line. If you had, say, 2 and 5 in the circles, you'd have to have 3 and 4 on the line. So that's between lines rules. However, every one of these lines also acts as an arrow, but we don't know which end is the real circle. So along here, for instance, one end is the sum of the other 3 digits on the arrow. So the other circle is involved, and the arrow is adding, the circle digit is adding the other 3. So somehow these two rule sets have been entirely combined by Niverio, not a given digit in the grid, and yet apparently this solves uniquely. That just seems astonishing to me. It's one of these feats. I have a fair chance that this is right, that this is one of those rule sets that's a really very interesting idea, and yet Niverio has created the perfect puzzle with it straight away. That may turn out not to be true, but it is a phenomenal idea. So just to repeat, numbers on the lines must be between the numbers in the circles, and yet one circle adds up all the other numbers on the line, including the other circle. Incredible. Really interesting rule set. Do give it a try on the link under the video, and I am going to try now. Let's get cracking. What the heck do we look at? If there was an arrow, if there was a line that was 3 digits long between two circles, that would be impossible, because then the arrow circle would be adding 4 digits. But then they could repeat. Actually, that wouldn't be impossible, but it doesn't seem to happen here. So I mean, I don't know, take this line. It's all in one box. Now, one end of it has to be 6, 7, 8 or 9. Oh, the other end also always has to be 1 or 2. Because any set of 3 digits that add up to a Sudoku digit, the smallest one has to be 1 or 2. And the smallest one must always be in the circle so that the between line rule can operate. So if we had a 6 in a circle, say here, then these 3 would be 1, 2, and 3. And because of the between line rule, that would be 1, and these would be 2 and 3. So I suppose one of those 2 digits is a 1 or 2, but then that can be as well. Ah, okay. Yes, here's a thought. This might be better. This is better. Right. Right. Imagine... Yeah, this is going to matter which end of these arrows, if you like, treating them as that for a moment, is high and which end is low. So, if this was the high end of this arrow, then just assume for the sake of argument that this was the high end of the other arrow, although it doesn't matter, it could be that end. But we'll assume those are the 2 high ends. Then these 3 add up to that sum. These 3 add up to that sum. Actually, let's do it the other way around. Let's do those 3 and those 3, with these circles being the sums. Now, those 6 digits would all have to be different, adding up to a minimum of 21. And those 2 circles would have to add up to 21. And even if they were both 9, they're nowhere close. So that doesn't happen. Now, what is the way we can stop this impossibility happening? It is by this being the high end of this arrow. So I'm going to write in 9, 8, 7, and 6. I don't have to worry about a repeated digit because you can't have one. Well, you can't have one on this shape of arrow anyway, because theoretically, if this was just a regular arrow, you could have a repeated digit there and there. But since this is on a between line, you can't have a circle and a digit on the line being the same. So 1, 2, and 3 is the minimum. 9, 8, 7, 6 there. Now, the point here, I still don't know which of these 2 is the high end, but whichever one isn't is part of the arrow cells in the box. And they have to add up to at least 15, because the minimum they can be is 1, 2, 3, 4, 5. Therefore, the two circles involved have to add up to at least, well, they're going to add this item as well. So not 15, but that is going to have to be a 1 or a 2. And the 2 circles, which are both in this box, are going to have to add up to 16 or 17, depending on whether that's a 1 or a 2 and what the 5 arrows here are. Now, that can't be a 6. But it could be a 7. These must be from 1, 2, 3, 4, 5, and 6. Now, I know that the 5 arrow cells in this box will either be 1, 2, 3, 4, 5 or 1, 2, 3, 4, 6. That's all they can be. I don't know which of these is the other small number. And this box is the same, isn't it? This is the same. It's got the same pattern of arrows. So this number on the arrow that goes out of the box has to be high. That is 7, 8, or 9. Again, these are from 1, 2, 3, 4, 5, 6. This has to be 1 or 2, just like the arrow that comes out of this box. And that means we've got a pair. That looks useful. So those can't be a 1 or a 2. This can't be a 1 or a 2, and the smallest number, the small circle in a 3-cell arrow, is always going to be a 1 or a 2, I think. So that is 1 or 2. One of those can be as well, though. So what the heck? So this can't be 1 or 2, but again, this is a 3-cell arrow, so that must be the small end. That's a 1 or a 2. Now we've got a pair in column 3, and that can't be a 1 or a 2. This is, well, a high number. Does it? I suppose it's 3 cells. And the smallest this can be is 1, 3, and 4. So that's an 8 or a 9, because you can't use both 1 and 2 on this arrow, clearly. This can't be a 1 or a 2 now as well. So the low end of that arrow is here. That is a 1 or a 2. These two are adding up to 16 or 17 to encompass all of those cells. So that is 7, 8, or 9. This is a strange puzzle, but this is very clever. Now, whatever that is replicated in one of those cells and must be on this arrow. It's not that useful. This one is 7, 8, or 9, because these two have to add up to 16 or 17. And these 5 are now the cells that are 1, 2, 3, 4, and either 5 or 6. Of course, 1 can never be on a between line. That's an important rule in between lines normally. And it still applies here. So 1 can never be on a between line. So in these 5 cells, where's the 1? It's clearly in the circle. Right, so that gives us 2, 1, 2 there. This now must, I think, be, yeah, these have to be a 3 and a 4, because they come between 2 and whatever's here, which is now 9. So that's not a 9. We can't have 3 or 4 here. So we've got to have a 2 on the line. And this is now a 5, making that an 8. Those are resolved. This becomes a 9. Oh, well, this was going to be 3, 4 now, since we got that 2 anyway. This is not a 9, but these two have to add up to at least 16. So this one is a 9. That doesn't necessarily make this 2, 3, 4. That could still be a 1. There's a 9 on this line. Well, it can't be on the line. It has to be in one of the circles. Oh, and there's either, whatever that is replicated here and on the line. So it's either 1, 2, 9 or 7, 8, or, sorry, it's either 1, 8, 9 or 2, 7, 9. This is a 6, 7 pair in the box. Let's just do some regular Sudoku. Right, this line can't have a 2, 3 or 4 on it, because there's a 3, 4 pair here. So it's got to be 1 plus a higher number, because otherwise you'd be into 5 plus 6 equals 11. So one of these is a 1. I could have worked that out, actually. Oh, from those 1s. But look, those 9s are also saying there's got to be a 9 on the line. That's also got to be in the ends. So it's 1 plus 8 equals 9, like that. Don't know which way round, but 8 there means these are from 5, 6, and 7. 2, 2, 5. No, I don't know what to do. Right, let's have a look. Right, this is a 7 or an 8. So this is either 2, 4. Well, it can't have a 6 in it anymore. It could be 1, 5, 2, 1, 4, 2, or 1, 3, 4 in any order, which is annoying. Come on, keep thinking. 8, 8. This has to be 8. Right. This is a 7, and that finishes its arrow. 2 and 4 there. This is now a 1. These, I think, have to be a 3 and a 5. Yes, they do. That's a 3, 5 pair. We get 6 and 8 here. This is 5, 6, or 7. No, not 5. That's in the row. So that's 6 or 7. Now we've got a 5, 6, 7, 8 quad. Oh, it's got the same thing with 1 and 9. They both have to be on this arrows. So they're in the circles. That's an 8 in between. That makes that a 6. That makes this a 7. That's a 6-5 pair, which fixes this. And we are away to the races. 3, 4, and 6. I feel like I'm cooking with gas for once. 3, 4, 5, and 7 are the possibilities up here. Have I missed something out? No, I haven't. No. 1, oh, hang on. That 6 sees this, right. 5, 6 there. 3, 5 here. That looks up to the top. 4, 3 there. And that looks across to here. 4, 3 there. We can take 3 out of those 2, 4 out of those, and we have a triple and a couple of pairs in box 2. Right, we also have triples at the bottom of columns 1 and 3, which are all even on the left, all odd on the right. But now we have to approach circles and arrows and lines that we haven't looked at. This is a 3-cell arrow, and it cannot have 9. Yes, it can't have 9 in the circles. That's incredibly useful, because as soon as the top circle is less than 9, a 3-cell arrow has to have a 1 on, and that has to be in the other circle. Well, this can't have a 1, so the 1 is here. This is now 6, 7, or 8. Because that's a 2, 5, there can't be a 5 on this line, because if this was 2 and 5 to make that 8, whatever was in there would clash with the 2, 5 here. So these cells are from 2, 3, and 4. That one can't be 2. I don't think we can do more than that here, but this is 2, 4, 6, or 7, just by what it can see. This could be 8 as well. That doesn't feel that helpful. This one is 1, 3, 5, 6, or 9. I don't think we can resolve this at all yet. So what about this 3-cell arrow? 9, 4, 3. This can't be 1 or 9, but it could be a 2. No, that wouldn't work. If that was a 2, you'd have to have 3 and 4 here to make 9 here. But that can't be 3 or 4. So this is not 2. So it's not 1 or 2. This is the high end, and this is the low end. So that's 1 or 2. This is 8, 7, or 6. So we do need a 1 on the line, and that goes in the circle, and that is a 1 there. Now, again, we have a 1 to go in one of these 2 cells by the Sudoku of having that in row 7 and that one in row 9. Oh, this is lovely. Now this one can't be 1, 8, 9. But I don't know what it can be. Right, 1, 6. Does this have to be a 2 because that's a 3, 4 pair? No, I think it could be a 5 with a 2 there. Remember, the numbers on the arrow don't have to be in order. They just have to have the lowest one in the other circle. Right, what am I missing now? 9 can't be on this line, can it? Because of that 8 being there. If 9 was on this line, it would be 1, 8, 9, and that's impossible. So 9 is in one of these 2 cells. And therefore 9's in one of these 3, but 9 can never be on a line, so 9 is there. Which gives us a 9 here, and in one of those 2, and that's, oops, not like that, and that's another X-wing with 9's up here. So the 9 in column 5 has to be in one of these 3, and we know where that is. It's on a circle, and not here. Now, this can't be 8 because that can't be... Oh, this has to be the smaller one. So it can't be 6 or 7. So this is 7 or 5 to go with 2 or 4 there. This now can't be 9. What's going on in the middle here? This is 2, 3, 4, 5, or 7. Well, it can't be 7. This probably isn't the sharpest way to attack this, but... I'm going to keep looking at this for a bit. This can't be yeah, it could be a 2. Oh, I don't know which is high and which is low. Okay, forget that for a bit. This one by Sudoku is, it sees 6, 7, 8, 9 there, 5, 3, 1 there. That is 2 or 4. So we've got a little weird triple going on. 5 now has to be in one of those 2 cells. I'm putting it in the middle. 6 and 8, oh, could be there or in one of these 2. And 7 can't be there. 7 is in one of those 2. So the candidates have got very, very restricted there. 6, 7, 8, 9. Right, down here, we've definitely got a 5. These are from 2, 3, 4, and 5, and one of them is a 5. Could be a 5 there with a 2 here. 9, 1, 2, 5. What's going on down here? Nothing much. Oh, I'm missing something here. Come on. Oh, look, a 2, 4 pair. Bingo. That is really interesting because now this can't be the small number. That has to be the big number, even in a 2-cell arrow. That has to be the big number. So this is the small number. It can't be 5. No, it can't be 5 or 6. It's the smaller of the 2. So that is 1 or 3. This now is 5, 6, or 4. Well, it can't be 6. So it's 4 or 5. 1, 5, 6. And 3, 4, 7 are the 2 possibilities. It's going to form a virtual pair with that. Oh, never mind about that. Right. So we've got 2, 4. So this is 6, 7, or 8. Come on, come on. These being all odds and those being, oh, sorry, all evens and those being all odds doesn't help make this happen at all. No, I'm not seeing what to do. Right, let's have a look along here maybe. 7, 2, 4. No, I don't think that's that interesting. Right, what if this was 3, 4, 7 then? You'd get 5, 6. Yeah, that doesn't work. Right. Oh, look, there's an X-wing on 1s. Good grief. I spotted the X-wing on 9s involving this barbell up here. But I did not spot the X-wing on 1s that we've created, which mean that the 1s because 1 has to be here in row 2 and 8, 1 can only be here in columns 4 and 6 in these 2, and therefore in column 5 there is a 1 in these 3. We now know what's going on. 1, 5, 6. Just want to check as we do that. That can't be 6. This can't be 6. 7 or 8, that doesn't figure that one out yet. But this has now become 4. This can't be 5. What have we got in the column? 2, 3, and 7. This can't be 7, or we would need an 8 or a 9 in one end of the barbells. 2 or a 3 there, and there's definitely a 1 on the line. So this is either 1, 2, 3 or 1, 3, 4. That doesn't quite give me a triple. Probably gives me another crazy X-wing that I'm not seeing. Oh no, look, that 5 has sorted this out as a 7. That puts 8 here. So this is a 3, 4 pair. That's a 2. Here we go. That was the approach. 4 there. 5 there. This can't be 4. That doesn't make this the small end on its own. This is a 7. 4, 6, 7, 5, 1. So this is now a 9, 2 pair. We can fill them in. This is a 3, 8 pair. I can't fill those in, but I can do 6 and 5 over here now. This becomes, 6 or 8. 1, 2, 6. I don't know what's going on there. One of these, yeah, we knew that. Oh, they're not 2 now. So this is 3, 4, or 5. So we've got 2, 6, and 8 down here. Well, this one can't be 6 or 8 on this line. That's nonsense. So that's a 2. This is now 3 or 5 to make that work. This is now 3 on the barbell. So this is 1 and 4. Lovely. So we get a 5 there, 8 there. That 1 and 4 is sorted out 1 and 9. We've done nearly every cell on a between line or an arrow. Not quite though. Haven't sorted out this 3-4 pair yet. That's a 6. That's a 6. That's a 7. This is now a 3, so that 3, 5, 7 triple has been done. Not so the 2, 6, 4 triple. This, 3 has sorted out the column. 7 there, 2 there. That does sort out the 4, 2 triple. What a puzzle this is. I love it. It's just gorgeous, isn't it? It's just gorgeous. The logic in this is perfect. I mean, this is exactly what I said would happen, is that Neverio has created the perfect example of this puzzle. And that really is a piece of work. I mean, that is a lovely idea and a perfect execution. I'm so impressed when something is as literally beautiful as that. That is such fun to do. Thank you if you followed along. Well done if you did it yourself. That's real class. Good work, Neverio. Thank you very much for sending that to us. And really looking forward to your next puzzle. Really looking forward to tomorrow, as ever. Simon Stream on Tuesday, Looney Tunes on Wednesday on Patreon. Let's go, and bye for now.